Here's a physics question about a particle moving through a magnetic field. This is the worksheet I received from someone, and as you can see, for some reason, it gets sent as a full-size thing and everything is clear, and then it arrives as a thumbnail. And when I try to zoom in, it's all blurry. So I think I'm going to work number 11 on this one. I think I got everything right. I don't know if I have the numbers right, but this is what I got from it. I got that a proton experiences a force of 4.1 times 10 to the negative 11th newtons when it travels at right angles through a 0.61 Tesla magnetic field. And then the question is, what is the velocity of the particle? I thought I wrote this in. Yes, I did. Q is the charge on the particle. On a proton, this says it's a proton, it's approximately 1.602 times 10 to the negative 19th coulombs. Sometimes it's written as 1.6 times 10 to the negative 19th. I'm going to use 1.602. The velocity is the velocity in meters per second. Don't know. That's what the question asks for. B is the field strength in Teslas. Again, I don't know if all these numbers I read correctly, but from what I could see, it was 0.61 Teslas. If any of these numbers are wrong, put in the right numbers from number 11. If you get a different number, or someone may have the worksheet and you've got it full size where you can actually see it. F is the force in newtons, 4.1 times 10 to the negative 11th newtons. And theta is the angle, and it's sine of theta. Well, the angle is 90 degrees. Sine, what happened there? I couldn't even write an S. Sine of 90 degrees equals 1. So here's the formula, QVB sine theta, and I need to solve that for V velocity. I will divide both sides by Q and B and sine theta. So force divided by Q times B. Sine theta, sine of 90 is 1, times 1. I can write it, but I don't have to write it, equals the velocity. So now I just plug in the numbers. The force is 4.1 times 10 to the negative 11th. And again, if I've read any of these numbers wrong, just put in the right numbers. Divide it by Q, the charge on a particle, which is a proton, 1.602 times 10 to the negative 19th coulombs, times B, which is the field strength, 0.61 T, times the sine of the angle, right angle, 90 degrees, which is just 1. So that's it. And if I write it here, I've already done this in Desmos, comes out to 420,081,967.2. 420,081,967.213. And if I write that in scientific notation, 1, 2, 3, 4, 5, 6, 7, 8, it's approximately 4.2 times 10 to the 8th, and it's in meters per second. It's pretty fast, but that's the answer I get with these numbers. And I'll remind you just one more time, my numbers may be wrong because of this email decided to just attach a thumbnail instead of the actual page, so it's blurry to me. So if the numbers are different, put in different numbers. But that's how you find the velocity given a particle type going through a certain magnetic field at a certain angle, and there's a certain amount of force experienced by that particle. The force equals charge on particle times the velocity of the particle times the field strength times the sine of the angle. And there's your answer, 4.2 times 10 to the 8th meters per second.